As I mentioned in the previous video, Cybox is under active development, and that means that the interface that you see, the details here, may be subtly different than the version that you've downloaded. That's because we're getting suggestions from people like you about how to redesign it to make it work better, so please do send us those suggestions. Cybox can currently import and export information in two different formats, CSV or lipid. CSV we all know about. It's common and flexible, but not very rich. What I mean by that is that it doesn't allow you to encode metadata in your file in a systematic, machine-readable, semantically useful way. Metadata, if you remember from the first video, is data about the data, and it's formally linked up in a way that captures the meaning of the relationship to the data. So it's not just a note somewhere in a cell in the spreadsheet that you ran bacon with thus and such parameters, but rather the information about the run and the parameters is stored in Cybox's database and shown in its GUI. With CSV files, there's also the problem that people can name the columns differently. If you have temperature, for example, you might call it temp. You might call it temperature. You might use a capital T or not. To a computer, those are all different, and it's surprisingly hard for a computer to deduce that you meant the same thing by all of those. These kinds of things are some of the banes of interoperability and data sharing. Lipid is the linked paleo data framework that is being developed by Nick McKay and Julien Imilger at USC to solve those problems. In this video, I'll demonstrate how to import and export CSV files from Cybox, and then I'll end by explaining how to import and export lipid files. Cybox knows about a ton of different quantities. You can see all of them, if you're interested, by selecting the All view in the grid. Incidentally, the Calib column here is data that came in with this record. That is, someone ran Calib, the version from Queen's University from this web page, on this core before it got imported into Cybox. You'll recall that one of Cybox's built-in computational blocks does a Calib-style calibration, and that you can assemble that block into Cybox computation plans, and then you can run them. It's a useful check that the calibrated age produced by that run of a Cybox workflow is consistent with what Calib 7.1 produced on this same core. We've also checked that we line up with Oxcal and Bcron. Back to importing. Here's a simple example core that I've cooked up. The import wizard's task is to guess, from the column header names, the mapping between the data in each column of the file and Cybox's internal variables. The import and export facilities are in the File menu. You have the option to make a new core or add your data to an existing core. You have to enter the latitude and longitude, or Cybox will yell at you. Again, I'm just making something up here. If you wish, you can enter the global unique core identifier, and you can make notes about provenance. Now comes the interesting part. The names in the gray part of each row are the names in the headers of the CSV file. The names in the white boxes here are the internal Cybox variables that the import wizard has guessed that each one of these corresponds to. It guessed right with depth in this column, and it also figured out that this parenthesis CM parenthesis meant that the units were in centimeters. But it struck out on the other two columns. So you, the user, have to help it get the mapping right. How to do that? You use this dropdown to specify which internal variable that column of data should go into. This should obviously be mapped to the internal variable named 14ch. Now, watch what happens when I click this. Cybox has brought up a small interface here that lets you tell it whether 14ch has an error or not, and if it does, whether information about that error is in one or more of the columns in the CSV file, which appear in this dropdown. This spreadsheet does have a column containing data about the error in the 14ch, so I'm going to select that column here. Now Cybox knows exactly how to suck in all of the information in that CSV file correctly. You've just given it some metadata, by the way. You gave it data about the data. Here, it was the knowledge that the third column in the CSV file was the error in the second column. Remember, computers are dumb. They have to be told these things. I'm going to finish the import now by clicking Next. And there's the data. You may have noticed that the error in that example was symmetric. It was plus and minus 8.47 or whatever. Here's another example where the error is asymmetric. And here's how you import that data. You use the asymmetric error tick box, which brings up boxes that allow you to select which column is the plus error and which column is the minus error. The exporter exports all of the data columns that appear in the grid, so you have to set things up the way you want them before you select Export Samples from the File menu. Let's say we've run SimpleCalib plus linear interpolation on the Pacific Deepwater core and we want to export that information. There are a bunch of files here. A main file that has what was in the grid, and a bunch of other files that have the error distributions that you could see by clicking on the points in the plot. A big caveat here, the current version of Cybox can export these error distributions, but it cannot import them. That would have been a really nasty mess of code with a complex user interface. We did not take that route because Lipid makes that process easy because of the metadata that it stores. Also, information that's in the Lipid framework doesn't need effort on the part of Cybox's import wizard because the formatting and naming of the variables are all in the Lipid object already. That means that importing Lipid is incredibly simple. You just click Import Lipid, and it just works. The same thing with exporting Lipid files. Now the difference here is a bit subtle, but it's important. With the CSV export, you get a bunch of CSV files, one for the error distribution of each point, and the only semantic link between the different pieces of information, that is, which file is the error distribution for which point, is the names of the files. With Lipid, all the stuff gets exported in a format that captures not only the raw information, but the ways in which everything is related. Those are important parts of the power of Lipid. Another part of that power is that any other software that knows about Lipid can seamlessly work with these files as well.